Hello and welcome to the tutorial for Tinkercad. Today we're going to sign up for Tinkercad and use Tinkercad circuits, and I'll show you some of the basics. We'll just go to tinkercad.com, and once you're there, you're going to click join and sign up. For this one, you can either do students join a class. We don't necessarily have a school set up here, so you can actually just use create a personal account. A useful program or useful website. You can use it for other things besides just your classwork. Provides a full online electronic workbench. Go ahead and click here. You can use whichever email you like. You could use your school email or your Google or Apple account. Looks like there's a couple of more options. I already have an account, and I trust at this point that you guys are comfortable signing up for accounts. So I'm going to log into mine. Once you have your account and you've verified it, you go back to the screen, sign in, going to username, and all of my information is still kept here. You can click stay signed in. That'll keep you logged in next time you come back. Okay, once you have logged in to your Tinkercad, a few notes about this. Tinkercad itself is actually a very simplistic CAD program. This is not as advanced as, say, Onshape or AutoCAD or SolidWorks, but it is a system that you can use to create basic three-dimensional objects. But over on the left-hand side, we're actually going to click on Circuits. And you can see I have a couple of circuits already made from testing out various things. But we're not going to use any of these today. We're going to click New, Create New Circuit. When you start yours, you probably won't have anything here. So we'll click Create Circuit. It'll take a moment to log in. Okay, so let's take a look at what we've got here. We've got a basic ribbon command up here. We've got a rotate button. We've got a delete button, an undo, and a redo. Annotation, this is the same thing as comments, and a view and hide. In the top right, we have a code. This is where you can actually write code for the Arduino that's built in here and run that code. Unfortunately, this won't run MATLAB code, but it may be useful for you later in the quarter when you're doing some of the other Arduino stuff. We have a start simulation. We can actually build and test circuits in here. We have an export. This will allow you to export your entire circuit and use it on something else. We have a component list. This will essentially create a bill of materials as you build your circuit so you can show what you've used. And a share, so you can actually share it to your friends or schoolmates to see what's going on. Below that, we have a components. Most everything we're going to need for right now is in BASIC, but go ahead and you can click on all, see all of the different components that are available. They've got LEDs and ring lights and different breadboards and different controllers and op amps and all sorts of stuff that is just beyond what we need right now. So I'm going to switch back to basic. And let's build a really simple LED system to start. So everything is kind of a click and drag. So we're going to click and drag it out. Because this is a web program, it can take a second for everything to respond. So when you click on it, you notice it highlights in blue. We can either click the rotate button, you notice it rotates in sections, or you can press your R key. I'm a big fan of hotkeys, so I usually use R. For this example, I think it makes most sense to have my circuit vertical, but you can set it up however it's comfortable for you. Going to click and drag an LED up. Now, the same thing happens with these. You can rotate them. The way it brings in the LED, it's not super useful in the breadboard. You see it actually snaps into the breadboard slots, which is nice, but remember that these rows are all connected together. Like, you actually see that here, which means that this LED won't ever work. So I'm going to pick it back up, and I'm going to hit R a couple of times so it rotates sideways. And I'm going to plug it into my breadboard. Go ahead and plug it in over here. The bent leg is the positive, or if you mouse over it, it's called the anode. Anode is positive. And the negative leg, or the cathode, is the straight leg. Let's bring a resistor out. Now, the resistor, when you bring it out, is just a generic resistor. But you'll notice up in the top right-hand corner here that we've got a name and a resistance here. Note that it defaults as 1 kilo ohm. For this one, we're going to just make it just like we had in the first Tinkercad circuits. So I'm going to change it from the kilo ohm back to just normal ohm. And I'm going to set that as 330 ohm resistor. The colors change. It should look just like you had before. Remember that these are passive, non-directional components. So it doesn't matter which way we put it in, but I'm going to rotate it, and I'm going to put it on the positive, the anode leg of the LED, and I'm going to go across the bridge. I'm going to make a really simple circuit here to start. So in this case, I'm going to also drag out the Arduino. Do note that the Arduino looks a little different than yours. This is a standard Arduino. You guys have one from SparkFun. They're red. They look a little different, but the pins are the exact same. So I've rotated that so it's vertical. In this case, I'm not going to program the Arduino, but I'm just going to use its 5-volt out. So I will click on the 5 volts right here. You notice a line is created. It defaults as green. That's fine. If you hold down Shift, you will notice a blue line pop up whenever you hit a horizontal line. So we're just going to bring it somewhere over here, kind of create a horizontal one. Doesn't need to be perfect. You can change these afterwards. Click. Once you click, it allows you to essentially bend the wire. So we'll bring it up to about where I want it to go. Click, and then I'm going to bring it over and plug it in 2. Once you've finished running it from someplace start to finish, you notice in the top right-hand corner, you have a color pop up. I'm going to change this to red to indicate that I'm using power. Note that I can also grab these little nodes, move them around to clean the circuit up, make it look nicer, get everything nice and perfectly parallel with each other. There. So I now have a 5-volt source for my Arduino that goes in. Now I'm going to go from 1F. I click on here. I'm going to bring it over to ground. Click. Here, click, and click. And then once again, I'm going to change the color to black so that I know that that is a ground wire. And then I will click off of here. You can click on any of these wires and delete them. Another thing to note is you can start a wire from the breadboard and go out wherever you need. And then when you're done, you can just hit escape. They do have to start and end on a node or a component. You can connect these components directly to each other instead of a breadboard. But for our example, we're going to use the breadboard just to keep it clean, and it's what you would actually see if you were building the circuit. So now that we have everything up and going here, we're going to simulate the circuit. So if we go to the top right-hand corner, we can click Start Simulation. And what this does is it starts the simulator. The Arduino is running. Looks like it's even got the Blink script started, but we'll come back to that in a moment. The 5-volt power comes in, goes across our resistor, goes to the LED, comes through the cathode, back to the ground. You're done, you can hit stop. The LED turns off. Let's go ahead and take advantage of that Blink script that's already here and see if we can't make it blink. So this is much like your first Tinkercad example. This light is connected to pin 13. So I'm going to run it up from here. So instead of the 5-volt, I'm just going to pin 13. And I am going to use a yellow line for this, just to demonstrate something. I like yellow for signal. It just works best for me and how I think. So we'll click Run Simulation. The code is running. Line 13 blinks. You can see the LED turns on. Once you are done with your circuit, fortunately, there's no good way to just grab all of this as a picture. If you're on a Macintosh, this will be a little different. You may have to look it up. But on Windows, we are going to use the snipping tool. So open up the snipping tool. And in the future, they may change this. But for now, we're just going to use the snipping tool. Mode is square, so we're going to click New. We're going to drag a box over whatever it is we want to snip. In here, you can see we've saved an image of what we want. This can be copied and pasted, but it's probably easier to go File, Save As, and save this someplace that makes sense. And we'll call this Blinky Circuit. You'll want to name this whatever Tinkerkit you're working with, but name it something that makes sense to you. I'll save it. It is now in that folder where I saved it, and I can use that on whatever I'd like. I'm going to go ahead and close the snipping tool. See, a couple things to know. You can use the mouse wheel to scroll in and out. Center mouse button or the mouse wheel, if you click, will allow you to move around your circuit. And most everything else on here should work exactly like you would expect. Almost everything that is in your Tinkerkit is in here, so you can simulate your circuits in here. We have motors, we have hobby gear motors, you have some of these in your Tinkerkits. We have servo motors. There's switches, RGB LEDs. We even have ultrasonic sensors. Note about these ultrasonic sensors. These are 3-pin ultrasonic sensors. The ones you have in your kit are 4-pin. These work very similar, but they're a little different, so they may not work well for you. We have photoresistors. We even have multimeters. Now, I want to show this off real quick. So same thing on here. I'm going to take the negative. I'm just going to run it over, and I'm going to plug it into the negative side of my circuit. I'm going to take the positive side, go down and connect it to the positive side of my circuit. Now, you can see I left these as green. If you click on them afterwards, we can change the color. So let's go ahead and set that as black. Set this as red. That way I just know negative and positive. Right here you can see I have it set to V. V is voltage. If we start the simulation, what we should see is our voltage will jump up and down to just about 2 volts. And now we can see the voltage in our circuit. A is for amperage. You can test out the amperage of a circuit. This is done in series if you're ever trying to do that. So just an example. Voltage is always done in parallel, so it goes with your circuit. So it would go essentially across your LED. But if I were to change this so that I can do the amperage, we're going to change the mode here to amperage. Amperage goes in series with a circuit. What that means is it has to be part of the circuit or it will not work. Can't use it to go around. So we'll go ahead and start the simulation. And this probably see very much. In fact, in this case, it's not working at all. Oh, make sure to complete your circuit. There we go. There we go. Now we can see that it pulls about 7.31 milliamps every time the LED turns on. Okay. I do recommend making your circuits a little cleaner than this. I just wanted to demonstrate. If you want to get rid of something, just click on it and click delete on your keyboard. It goes away. That is the basics of using Tinkercad. Things auto-save in here, so as soon as you leave, it will just save. And you will notice if you up in the top left-hand corner, it creates a name for you. This may not be a useful name, so it's helpful to click on it. Tinkerkit, we'll do Tinkerkit 1, and it renames it. Now it's saved and ready to go. That is the basics of Tinkercad. If you have any problems, let me know. Thanks.